Good afternoon to Dr. Lee Lek Chuan. Today I'm going to talk about the manufacturing process individual assignment. My name is Yi Jian Ming from section 3 and my topic is multi-jet fusion MJF in 3D printing. First of all, I would like to talk about what is MJF. Multi-jet fusion is a 3D printing technology that uses powdered thermoplastic to quickly generate precise and finely detailed complicated objects. It can be reliably and swiftly deliver parts with high tensile strength, excellent feature resolution, and well-defined mechanical characteristics. There are some applications for multi-jet fusion which are parts requiring consistent isotropic mechanical properties, functional prototypes and end-use parts, and complex and organic geometries with fine features. Besides that, I would like to talk about the material that MJF uses. Material used for MJF include rigid plastic and flexible plastics. Rigid plastics include nylon PA11, nylon PA12, and PP, while flexible plastic include Extend 3D TPU M95A, as shown in the picture besides. After we know the material that's used for MJF, I would like to talk about the step of how MJF build parts. The first step is the movable build unit is placed into the printer. Then, the material recruited carriage moves across the build area, depositing a thin layer of the powder material. Then, the printing and fusing carriage move across the build area, preheating the powder to a specific temperature to provide material consistency. After that, an array of inject nozzles fuse agents onto the powder bed in areas that correspond to the park's geometries and properties. After each layer is finished, the build unit retracts to create space for the next layer of material to be deposited. The last process is this process will repeat until the build is complete. After that, I'm going to talk about how does multi-jet fusion work. Multi-jet fusion employs an inkjet array to selectively apply fusing and detailing agents to a bed of nylon powder, which is then fused by heating elements into a solid layer. After each layer, powder is applied to the top of the bed, and the procedure is repeated until the component is completed. When the build is complete, the entire powder bed with the encapsulated piece is transferred to a processing station, where an integrated vacuum removes the majority of the loose powder. The parts are then be blasted to remove any remaining powder before being sent to the finishing section, where they are painted black to improve cosmetics appearance. Next, I'm going to talk about the advantages of MJF. MJF is excellent for building much stronger parts than what SLS can produce. Parts built with MJF have maximum tensile strength. It creates functional prototypes and relatively small production runs of an end-use parts. MJF consistently scans the surface of the parts is printing every pass, even if you are using it to print multiple parts at once to achieve its speediness. After that, I would like to talk about the difference between MJF and injection molding. With injection molding, you have to pay for the mold itself and undertake a lot of DFM analysis before producing the part. It is also restrictive in terms of part geometry and the lead time is significantly longer. On the other side, MJF allows for more expensive design freedom with greatly reduced lead times. So, you can also make design changes rapidly with MJF as you don't have to rely on the mold. In general, MJF is preferable for creating prototypes and for small and medium production runs. In a conclusion, MJF 3D printing is defined by its mix of speed, precision, and mechanical strength, making it perfect for both prototyping and production of end-use parts. As material options develop, so will its application, commanding its place in a wide range of industrial and commercial industries. That's all from me. Thank you.